Hi, my name is Serjan. I'm the Arnold Development Manager and I'm based in London. In this presentation, first, I'd like to give you an update on Arnold 6, including an Arnold GPU update. In the second part, we'll cover the USD integration in Arnold. If you're not familiar with Arnold, here's a few key points. Arnold was one of the first production path tracers. Arnold scales well for large production scenes and is able to render complex materials such as skin, hair, volumes, etc. Arnold is also customizable through a powerful C++ and Python API. We now have both CPU and GPU rendering with compatible results and the ability to switch from one device to the other. Arnold now ships with Maya and 3ds Max, and in those applications, Arnold is the default renderer. We also have plugins for Houdini, Cinema 4D, and Katana that we support, but there exist also unsupported plugins for applications such as Gaffer or Blender. Another thing is that we try to release as often as possible, once a month in general, but it can be as much as 19 releases a year. Similarly to what we had previously done for metals, we now have Microfacet multiple scattering for Dielectrics. This prevents the unrealistic darkening that we were previously getting when the roughness is high. And this is working also on thin-walled surfaces. Another feature that was added in Arnold 6 is a lens distortion model that is compatible with 3ds Max. Another thing we've added to the perspective camera is the ability to do tilt and shift. For convenience, we now ship an Arnold License Manager to set up your licensing, whether it's single user, multi-user, or using the legacy RLM server. And this is a sneak peek of our upcoming implementation of nested dielectrics in Arnold. Nested dielectrics is a system to define priorities on overlapping surfaces, such as ice cubes or bubbles within a liquid, or a liquid in a container. This makes it a lot easier to create realistic scenes with correct refraction. Last year, more than a quarter of the bugs we fixed were related to GPU. We are continuing to improve the CPU compatibility, adding support for missing shaders or features such as UV camera for baking, or the shadow matte shader. Recently, we added support of OSL texture and trace on the GPU. In terms of node support, we are getting closer, with just a few missing shaders. We have been collaborating with NVIDIA to load textures on demand on the GPU, instead of loading the entire texture up front. As you can see, this helps reducing the time to first pixel. On-demand texture loading also reduces memory consumption. Note that this is a work in progress, and that we are expecting bigger savings eventually. As usual, we bring a batch of performance improvements on both CPU and GPU, but as you can see on this list, a lot of them are related to GPU. Finally, let's have a look at a few examples of GPU renders. So there's the first one in Maya with realistic skin shading. Here's another example in Houdini this time, where Serjan Burlak is here rendering 25 million curves on the GPU. Here's another example in Cinema 4D to show you the interactivity. Here's the last example in Cinema 4D showing nice interactivity when tumbling the camera. Let's discuss the integration of USD in Arnold. We've been shipping Arnold with USD support since version 6.02, that was released in February. As this slide implies, it's been a labor of love and a top priority for Arnold. At SIGGRAPH last year, we had announced that the Arnold components for USD were being open sourced on GitHub under a very permissive Apache 2 license. While you can compile these components yourself, we ship them in the Arnold Core SDK and our various application plugins, so you can use them out of the box. The development process itself is done openly. Here you can see an ongoing sprint, and you can follow the development work being updated live. The current priority of features and bugs is also available and up for discussion. We encourage you to submit feature requests and report bugs on GitHub. Of course, you are also welcome to contribute and submit pull requests. Let me now give you an overview of the USD components and their integration in Arnold. The simplest way to ingest USD data in Arnold is to use the USD Procedural. It's just another procedural, similar to the Alembic or the AS file format procedurals. What this means is that you can use the workflows that you know and love in any of the applications we support, but with USD data. For example, in Maya, you can introspect the USD content, select items in the viewport or in the render view, and use operators for parameter overrides and assigning shaders. Sébastien will later give you a demo showcasing these workflows in depth. The procedural supports the vast majority of USD shapes. It's important to note that prim vars are translated as user data and thus available in Arnold to drive the shading, for example. While we support the few native USD shaders, this is not enough for production rendering. That's why we also support all the Arnold shaders as USD shade nodes, where the info ID attribute contains the Arnold shader type. We also provide USD extensions to support all the Arnold nodes as USD nodes. USD does not have a concept of operators or a definition for implicit surfaces, for example. You can also set Arnold-specific attributes on native USD shapes, like subdivision iterations on a mesh. They need to be prefixed with the Arnold namespace. In Arnold 6.02, we introduced a new scene file format API. This API allows you to create plugins to define how you load and save an Arnold scene in a custom file format. Now you've guessed it, we have such a plugin for USD. Note that AS, Alembic, and other file formats are also implemented as such. This means that we can now import and export Arnold scenes transparently in USD from any application we support. Moreover, the USD file will contain all the information needed to render with Arnold, including shaders, operators, render options, etc., like an AS file. You can also import and export parts of the scene, such as shader networks, in USD. Because we have a one-to-one mapping with AS files, we can render USD scenes directly with the Kick command line tool. Contrarily to AS files, because USD can contain an animation, you need to specify which frame you'd like to render. Another important USD component is the Arnold render delegate. This render delegate is very important for interactive rendering and easy integration in the applications that support Hydra, such as USD View. Stay tuned for more details about Hydra and see the Arnold render delegate in action demonstrated by Paul later in this presentation. Applications that support Hydra and thus the Arnold render delegate include Houdini Solaris, NVIDIA Omniverse, demonstrated last year at SIGGRAPH, or Maya USD. Paul will show you way more compelling demos later. But for now, I'm going to hand it over to Sebastian, who will present the USD Procedural and the USD workflow supported today in Arnold.
Hi, I'm Sebastian Ortega, and here I will show how USD can now be used as a scene format for Arnold, meaning that everything that is needed for an Arnold rendering, all the geometries, the lights, the shaders, all the render parameters, everything can now be fully described as USD out of the box. So here I have a Maya scene where the modeling was done, the shading, the lighting. There's a lot of Arnold-specific things in the scene, of course, shaders and lights, but also some Arnold attributes in the geometries and so on. And if I want to save out a USD file with all this data, I have to use the new menus, Arnold, Scene Export, and Export to USD. So either the full scene or selection, we have these options to just export the shaders or just the geometries. And now that's done. I've exported the whole scene to USD. And to show this, I can now open a terminal. So I'm out of Maya here, it's just command line. And I'm going to use the command that we have in Arnold to render standalone files in Arnold, which is called kick. And if I render directly the USD file, I can see that I have the exact same render with the same settings and nothing is missing. So here the file is fully self-contained. So of course, if I can render this in standalone, it means that I can also bring it in other applications. So for example, here in 3ds Max, I can create a USD node and bring back the file that I just exported and so that I can reuse it. So this means that we can have assets or shots that we bring from one DCC to another, and we have everything. So not only the geometries that we see here in the viewport, but also if I render, because we now can use the Arnold render view in 3ds Max, we can see that we have also the exact same render. So everything was brought, all the shaders, all the lights, and nothing is missing here. And of course, this also works also in the other DCCs that we support, so Houdini, Katana, and Cinema 4D. Now, if I go back to Maya, I'm going to show how to open USD files, and one of the ways is to use the Arnold stand-in nodes. So it's a proxy node that already existed to load Arnold standalone files, but now we can also directly load a USD file. Here it's the good old kitchen scene. By default, I just see the bounding box, but if I want to load everything, I can show really the geometry, and I can render it. So this is really the original untouched kitchen scene, and I see that it just renders out of the box. And one of the good things with the stand-in is that I can, for example, click in the render view and see both in the viewport and in my list here what I'm selecting, or select the list and see it in the viewport. So I can really see exactly all the contents of the USD file, but most of all, I can do overrides or do my look dev. So here I say that I want to assign a shader. I bring, for example, a car paint on the table and the chairs, and so on. I can do my whole look dev. So for example, I select the floor. I'm going to bring back, for example, a chrome shader. So I assign a new shader. I select standard surface. Here it is, and I can bring back a preset from the presets list, Chrome, and now I have a Chrome shaded floor. So we can use it to do all the shading. We can assign also displacement with this UI, but we can do a lot of different overrides. You can override all these attributes, which are the Arnold attributes for the meshes, the subdivision. We can hide objects, for example, if I select the fridge here, and here it is, and I do I assign a disable node here, the fridge is gone. I can also move objects if I want to. So for example, here the chair, I assign a set transform node, and I can apply a translation. So that's on one of the chairs. Here we go. So I can do a lot of overrides. And if I click on the Show Graph button here, I can see that this has created several nodes that were attached to my stand-ins. And these nodes are operators. So operators in Arnold are a powerful way to really apply overrides at render time. And it can be anything. We can assign shaders. Here I can enable and disable my transform operator that moves the chair. We can do a lot of different things. And we can also create several versions, so several looks. So here I'm creating a new look that I'm going to call props, for example. It's fresh new look, so I don't have any of the previous overrides. And I'm going to select everything except the props, and I'm going to disable it. So now I just see here the props. And I can switch between one or the other of the looks. And all this is, again, saved as operators attached to my stand-in. In which what is interesting here is that, of course, these operators can be brought back from one asset to another, one shot to another, or even from one application to another. So I could reload these operators from another application. I can use the menu Export Operator Graphs, and these operators can be saved as USD. So here I'm saving this. I'm enabling this option here. That means that I want to also bring all these new shaders that are created in the USD file. And that's done. Now I have created a file with all my look dev inside. So if I reopen a fresh new kitchen scene, the same as before, it doesn't have anything of what I've done before, but I'm going to reapply the same look dev with this USD file. So if I go back to the menu Operators, Import Operator Graph, I'm going to choose the same USD file that I had before. And this has imported all my operators. So if I open them in the node editor, for example, I see that everything is there. And by just connecting it back to my stand-in, I'm going to reapply exactly the same look dev. And this is really a powerful way to, for example, share the same look dev across different assets, or to bring them from one shot to another, or at the lighting stage if you have last-minute changes that you want to apply as overrides on a scene. And what's interesting here is that everything was fully done relying on USD. I have a stand-in loading a USD file. It could be a file exported with the menus I showed before, and then I have several overrides that were also brought with a USD file. So it means that it would work exactly the same way, going from one application to another, from Maya to Max to Houdini to Cinema 4D or Katana. I would always have the exact same render. So there's another way to load a USD file in Maya if you have the plugin Maya USD that is also open source in GitHub, which is using the USD proxy shape. So if I load Maya USD, I have this new menu, USD stage from file, and I can load the same file that we've exported before that had all this Arnold data inside. And so I can see here the geometries in the viewport, but what is really interesting is that if I render in Arnold, it just renders out of the box, even with all the Arnold shaders and lights that are not built in Maya, are not even built in USD. But still, if I load in the proxy shape and render in Arnold, I can see that it just renders. And I see all the Arnold nodes that are here, part of the USD file. And in Maya USD, there's also another plugin called M2H, Maya to Hydra, which allows to enable a Hydra viewer in the Maya viewport. So far, all that I've shown is released with Arnold and works out of the box. But there are several other modules in the Arnold USD open source repository on GitHub that, even though they're not released yet, they can already be compiled by the users. So for example, we have the Arnold schemas, we have the discovery plugins, and we also have the render delegate, which is meant precisely for Hydra. So if you have loaded M2H, you can switch the viewport to show Hydra in GL by default. And as I've done, you have compiled the Arnold render delegate module, you'll be able to render it in Arnold too. So here again, I have an Arnold rendering, I have the Arnold shaders and lights, but now this is going through the Hydra framework. So as I say, this is not released yet in the Maya plugin, but it has been released already in Houdini in several versions for Solaris, and this is shipped out of the box. So now I'm going to let Paul explain more in detail the Hydra framework.
Hi, I'm Parmazay, and I'm going to talk about interactive rendering using the Arnold render delegate. Let's begin with a very high-level overview. USD, the Universal Scene Description Repository from Pixar, is not a single entity but a collection of libraries and utilities with each covering a large topic. We have Base, which takes care of common tasks like math operations, loading dynamic libraries, or multi-threading. Next, we have USD that takes care of scene composition, defining schemas, and provides a large selection of ready-to-use schemas. Next is Hydra, which focuses on rendering and offers a base set of OpenGL, Metal, and other GPU interrupt functions. We also have USD Imaging, which builds on Hydra and gives us a Hydra scene delegate, OpenGL shaders, USD View, USD Record, and many others. Today, I'm focusing on Hydra. Hydra is a library that connects a scene delegate to a render delegate and produces images. It uses this scene delegate to generate a scene description for rendering. This could mean reading data from a USD file or host application directly, like Maya or Houdini. Then Hydra feeds the scene description to a render delegate, like the Arnold one. The render delegate interprets the scene and uses the underlying renderer to calculate and return pixel data. AOVs like color, depth, primitive IDs, or light path expressions. There are some other tools used to make this possible, for example, the node registry, which tells Hydra what shaders are available. We provide a render delegate and the node registry plugin in Arnold USD. The render delegate is using the Arnold core to render the Hydra scene description and return the AOVs requested. The node registry plugin generates a set of shader definitions, each representing an Arnold shader, containing the default parameter values and metadata. A great example of using Hydra is Solaris, Houdini's Lightning and scene assembly tool based on USD. Solaris recognizes our render delegate and the node registry plugin from Hydra, so it can compose Arnold renders over the OpenGL viewport. We can import the USD file from Maya and see the same results as in the previous presentation. The viewport remains highly interactive and performance is comparable to the Arnold render view. Instead of operators, we can use USD native workflows to modify and interact with the scene. For example, transforming objects like moving the helmet, creating and assigning materials like using a utility shader, or applying Arnold render attributes to objects like making parts of the body invisible to camera and shadow rays. Feedback of every change is immediately visible thanks to the fine-grained update information Hydra provides, and we can quickly switch between different representations of the same scene. Rendering is continuous because the Arnold universe is never shut down, so there is minimal downtime when making changes. We can also configure and preview Arnold AOVs using USD native primitives like the render var, the render product, and the render settings. AOVs works just like in other Arnold plugins, built-in AOVs like color and diffuse direct, light path expressions, or displaying render vars like UV coordinates. Again, everything is interactive, so I can change any AOV on the fly. USD and Solaris also supports the display of skin meshes, allowing the efficient representation of crowds. Here we import one of the example crowds and switch between frames of animation. While we already provide a plugin, Houdini to Arnold, that allows us to do interactive renders, the real power of Hydra that it lets us to target multiple applications using the same code. We don't have to deal with application-specific APIs, scene representations, or callback behavior. We support how USD and Hydra represents data, and that is uniform across multiple host applications like Houdini, Katana, or Maya. For example, here I'm using Katana's Hydra viewport and the Arnold render delegate to render the scene interactively. We get the same performance and interactivity as in Houdini. Selections and drawing over the Arnold rendered image works out of the box, because the render delegate provides per pixel primitive ID and normalized depth. We didn't add any Katana-specific code, just compiled the render delegate using the USD headers and libraries included in Katana. In the past, to support features like this, we had to deal with an application-specific API, something that can get complicated quickly. Here we just follow the Hydra conventions and the rest is taken care of. Next, we are taking a quick look at USD View. We can open the file exported from Houdini and render using HD Store, a streaming OpenGL render delegate, or switch to Arnold. As you can see, the materials are different between the two render engines. This happens because USD and Hydra supports specializing shaders for renderers. With this, we can use a single material for both preview and final renders. Another game-changer feature of USD that is designed to store multiple variants of the scene in a single file and only load what is required. In this example, we can change between variants of the stage. One of them is what shader are assigned to our meshes, one for quick ambient occlusion renders, one for final renders, and one for object ID preview. We can also use variant to switch between different lightings interactively, like a skydome light or two distant lights. Here, the lightings are not part of the scene, but we are switching between referencing two external USD files. This approach can be extended to store a shot in a single file, switching between different versions of animation, shaders, lightings, or effects with ease. This approach is highly scalable, so we can selectively access the data to compose the scene at any time.
Thank you, Pal. This concludes our tour of USD in Arnold, and I'd like to talk a little bit about what's next. If you browse the tickets on GitHub, you'll see that there is still a lot to do. This is a tentative list of the issues we are thinking of addressing next. And this is where we need your help with development priorities. If you are an Arnold customer and are interested in deploying Arnold and USD in production, we'd like to hear from you. Tell us what is blocking, what is not working, what you require for your USD pipeline. And this is exactly what we have been doing with these studios, and it's incredibly helpful. So big thanks to Luma, Rodeo, Superprod, Visten, Megalis, and Skydance. I'd also like to thank Pixar for creating USD, Side Effects, Otoy, and the Foundry. We've managed to collaborate in good spirits, and our common customers and the whole industry are benefiting from it. Thank you. Hi. Thanks a lot for watching this presentation. I hope you enjoyed it. So my name is Frederick Servant, and I'm here with Sébastien and Pal to answer any of your questions. So you have a way to submit your questions in the UI, and yeah, feel free to ask anything you want, and we'll try to answer as honestly as possible. Right. So let's get started with something. We have a question from Alex about the specular manifold caustics. So so about displaying caustics in Arnold, rendering caustics in Arnold. So at SIGGRAPH Asia, we released a paper, an academic paper, and Ian Georgiev contributed to this paper, describing a technique to render caustics in another way, and we are planning to implement this in Arnold, but the scientific research and the production, like the implementation in the production render is slightly different, but that's something that we have on our radar. So hopefully soon. So let's see. We have another question from German. In terms of Arnold, Houdini, and Hydra, would you say that these are beginning and new user-friendly? So how would one step into these? So that's a good question. So USD in general is a fast-moving target, and it's quite a complex technology. It's extremely powerful. It's more targeted at bigger studios, bigger pipelines, but we're trying to ship components that you can use out of the box. And I would say, so it's you have to learn a little bit about USD to be able to take advantage of this. But there are ways, as I described in the presentation, to ingest USD data very easily, and that's the first easy way to use the procedural. If you use the USD procedural, it's not different from what you are able to do with an Alembic file or an AS file. So I would start with this. Next, we have a question from John, and maybe I'll hand maybe Pal, you can answer this question. So the question is USD Hydra Delegate faster than, say, the H2A render view responsiveness?
Well, our goal is to have the same performance in both. We are aiming to minimize any overhead with the render delegate, so you should see the same performance in the render delegate as in the render view.
And I would add that currently, actually, the H2A render view is slower is less responsive than the Hydra Delegate. That's what I experience. But if you compare it to the Arnold render view in Maya, it's the same speed. Okay. I have a question from Mark, and I think this question is for you, Sébastien. Is it possible to view multiple Arnold viewports simultaneously in Maya?
Well, the answer is no. We cannot have multiple renders of Arnold currently in parallel. So no, you cannot have multiple viewports.
But I would say that's something that we're working on without further details. Next, so we have a question from John. Are USD overrides as flexible as Arnold operators? That's a very good question. Because USD overrides and Arnold operators, they kind of do the same thing, or not exactly the same thing, but there's a lot of overlapping functionality. I think and correct me, Pal, if I say something something silly. I think USD overrides are way more powerful, but and Arnold operators are you can use them without USD. So you could do this on USD or anything else, and they have another advantage is that they operate directly on Arnold data. Meaning that the interactivity, the reactiveness is really it can't be any faster than that, because we're modifying data that is in memory, ready to render. Whereas if you're doing a USD override, well, it has to be translated to Arnold and then rendered. So there's a bit of an overhead, but I would say it really so. Both are really powerful and really flexible, and you can go a long way. You can use both at the same time if you want, but yeah, they're as flexible. Paul, do you have anything to add to this?
Just a small thing. I think the real power of USD overrides is they are part of a single ecosystem, so you don't have to get outside of USD to apply your overrides. But Arnold overrides are a bit more flexible in terms of how you select the shapes that the override is going to affect. For example, the USD overrides don't have the regular expressions or the selection that we have in the operator. So you can just say that you want to operate on any node that which name is starting with, let's say, mesh, while you can do that with the Arnold operators.
Thanks, Paul. So let's switch to another question. So we have a question from Hernan. How much difference is there between the CPU and GPU in terms of feature? Hopefully not much. So in terms of features, we're closing the gap, and we've spent most of the half of the year to close the gap on like lots of missing shaders or features, and they're getting more and more. There's less and less. Like I showed a table in the presentation that was listing the number of shaders we support. I think it's 92% of the shaders. There's a few left, and there's also some specific features in OSL. Like we've just added the ability to use the trace function, to use the texture function, this kind of thing. So there are like still some differences, but hopefully you can get most. You can work with the GPU and have the same result as CPU. The way we've prioritized the features that are missing is through feedback. So we've prioritized the missing features on the GPU based on the feedback we're getting from customers from support. Notably, what is not supported on GPU yet is Cryptomatte, the toon shading, and off the top of my head, that's what I can think of in terms of big features. And we'll have them all. We'll have them all. It's just a question of time. All right. Okay, good question from Arash. Is rendering from USD Delegate slower than rendering using app? For big scenes, would you recommend staying with native, I would say, MB, so Maya file, or AS? That's a complex question. So theoretically, loading an AS file, like the AS file format, contains ready to render data. So there's zero translation, even there's zero memory copy, there's nothing happening. It's just reading the file and rendering it, basically. So in that sense, rendering with an AS file is going to be faster. But having said that, the USD files, especially binary ones, we're noticing that they're extremely fast to load. The AS files are pretty fast to load as well, but because of the binary format and like better compression, depending on your bandwidth. So if you have a slow network, for example, it can be faster. It can be faster, and there's a slight overhead loading the scene as USD in terms of processing and a little bit in memory, but not too much. It's really negligible. So I would say it depends. It depends on your scene. The fact also that you have an animation in USD, well, I don't know if that makes it faster, but like that takes less space on the disk. So eventually, it's going to consume less bandwidth on your network. So like Alembic, I would say. Right. So for big scenes, your mileage may vary because it's not just about the rendering; it's about the bandwidth, loading the file, and the space on disk. All right. Okay. A question from Michael. Lots of familiar names here. Thanks for that's a great presentation. Thanks. Any plans for an implementation of bidirectional path tracing? So that's I think the short answer is no. We're thinking of implementing other techniques, but bidirectional path tracing, we're not entirely convinced that it's something that is usable in production or useful in production. So a better question for me, but that's how we think about it now. Like the research might change, what I say now, but the real question is how do you do caustics? Maybe more. or there are other techniques, bidirectional path tracing, that we could use to have a better light transport, and we're looking into this. Okay, but bidirectional path tracing, as it stands now, very unlikely. I'm doing all the answers here, guys. Help me. On textures for now, as was stated in the presentation, with NVIDIA, because that's what consumes the most memory for now, and so this is what we're focused on now. But we have plans. We are very conscious that the memory footprint on GPU is pretty high now on the Arnold GPU compared to the CPU, and we're working on this also with NVIDIA. Next, we have a question that I'll gladly hand over to Pal from Gabriel. The question is: I read some time ago that USD is not yet standardized. Is it true?
Yes, it's true. It's not really standardized at the moment. It's quite a fast-moving target, and you can follow the development on Pixar's GitHub. Yes.
Okay, thanks, Pal. Short and sweet. And next, we have a question from Edouard. Hi, with the USD game changer, what do you think about improving on the operator side, like a user-friendly automatic tool? Anybody wants to answer this? Well, okay, I can start. So we all love user-friendly automatic tools, but sometimes it's not really possible. So for operators, and it's a workflow that is not necessarily tied to USD, because you can use this on any kind of data that Arnold can render. We have done a first pass of user experience improvements, specifically in Maya. And Sebastian, you demonstrated this in your presentation. Did you want to talk a little bit about what you presented in terms of like how the user experience is a lot more artist friendly for operators?
Yeah, if my connection lets me speak. So yeah, we've been doing a lot of work in Maya for the stand-ins, which is what I've been showing in the video, so that you can just select things and do overrides in a user-friendly way. There are still a lot of different ways to use operators on which we need to improve, and of course, yeah, we need to also port this to the other plugins, because for now this is only in Maya, and for in other DCCs like Houdini or 3ds Max, there's still a bit more of work to be done on the operators to choose to which object you want to apply an override, etc. So first we want to standardize in all the different products, but there is still a lot of different things that we can do to make it more user friendly. So it's just the beginning, yeah. And all suggestions are welcome from anyone, of course.
Yeah, thanks, Sebastian. I would add that in all the applications we support, we try to support like a native way to to use operators. So, you know, in Houdini, it's a specific context where you, in the ROP context, you can put operators, and they're full blown Houdini nodes. So it's going to be a little bit different in every plugin. There's a related question here by Kyle. Are there any plans on making operators easier to use for render layer overrides? Maybe that's another question for you, Sebastian. So, yeah.
Yeah, it's part of all the things that we can improve, render layers and render setup as well. Yeah.
Okay, thanks. All right, we have a question from Naviot. Is there a strong community presence adopting USD across the industry? Will other tools or companies be using USD as well? So, okay, that's coming from what I hear when I'm visiting studios, speaking to our customers. Yes, there is a very strong interest in USD, and I would say that this year is the year where a lot of our customers have been considering seriously migrating to USD. A few of them have done the leap. Actually, there's a few, but a few important ones, especially the ones that are developing brand new pipelines. Because if you have to do this at the moment, like it's yeah, you're very compelled to use USD to set up a new pipeline. But so I would say at the end of the year, most of the studios will have had a good look at USD. But so yes, those are strong signals. Last year it was a bit too early, I think, where there was a few very early adopters. I'm thinking of Luma Pictures. I'm thinking of course, Animal Logic and others. But this year, a lot of people are really experimenting seriously. So yes. Next question by Edouard again. Is something being developed between the Bifrost and Arnold stand-ins and operators? Yes. There's lots of development, and we have an Arnold procedural for Bifrost, or is it the contrary? Bifrost procedural for Arnold, that we actively developed. We actually have a developer that is embedded in the Bifrost team, make sure that this is working properly. And it's already shipping in Maya. And correct me if I'm wrong, Sebastian, I think this is part, the Arnold component for Bifrost is shipped by the Bifrost plugin, actually. So yes. And I would say it's very well supported.
By both actually. Yeah.
Okay. Next we have a hard but common question from Raphael. Hi, we use RenderMan in our studio. What would be the advantage of Arnold in terms of rendering speed? That's typically not really the question we like to answer because it really depends on the scene. First, I would like to say that RenderMan is an excellent renderer. We have a lot of respect for their work. We have taken like different. We have different history. We have taken different choices for implementing different things. It's the only advice that I would give is like try it for yourself with your workflow, with your assets, with what you're trying to achieve, and yeah, try it. That's all I can say. All right, I think we are running out of time. I'm not sure if we have the time to take one last question. I think this is it. So I think we're going to close it here. And thank you a lot for attending this presentation. And see you around. Cheers. Bye-bye.
Bye.